Hello everyone. In this question it is asked that if a, b, c are three complex numbers such that a plus b plus c is equal to ab plus bc plus ca is equal to abc is equal to 1, then we are to find the value of a plus b raised to the power 4 plus c raised to the power 4. Okay, so first of all, three values are given. We are given that a plus b plus c is 1. We are given that AB plus BC plus CA, this is 1, and we are given that ABC is 1. Okay, so these three values are given to us, and it is also given that A comma B comma C are all complex numbers. Okay, these are all complex numbers. So first of all, let us try to find the value of this. What is the value of this product? Okay, so we know the product of at least first two terms, right? This is given by x square minus a plus b times x plus ab, right? So this is the product of these two terms, okay, times x minus c. Okay, so let us try to find this product first. So after expanding the opening the bracket, we get x square minus ax minus bx plus ab times x minus c. Okay, so if we further multiply these products, these factors, we get x cube minus cx square minus ax times x is ax square minus ax times minus c is plus acx, then minus bx times x is minus bx square plus bcx, then plus abx, and then plus ab times negative c is negative abc, right? So let us try to see what can be taken common together, what can be factored together. Okay, we have x cube, then the coefficients of x square can be taken together in a bracket. We have minus a, minus c, and minus b. So if we take the minus out, we get negative of a plus b plus c x square. Okay, now let us try to take all the x, the coefficients of x terms. Okay, so we have AC here, we have plus BC here, and we have plus AB here. Okay, so let us write them. We have plus AB plus BC and plus AC. Okay, plus CA times x. Okay, these are coefficients of x, and then the constant term, which is coefficient of x to the power 0, is minus ABC. Okay, so this is the product of this. If you know the formula, it's very good. You can directly apply it here. Okay, otherwise you can just do this calculation in rough. Okay, so this is the product formula for x minus a times x minus b times x minus c. Okay, so we are given the value of a plus b plus c, ab plus bc plus ca, and abc. Okay, so let us put them here. So we have x cube minus, this is 1, right? So 1 times x square is x square, and this is 1, so 1 times x is x, and then this is minus abc, so it's negative 1. Okay, so can we further factorize it? If we take x square from the first two terms, we get x minus 1, and we also have a x minus 1 left out, so we can take plus 1 common, we can get x minus 1. Okay, so this now becomes x minus 1 times x square plus 1. Okay, now x square plus 1 cannot be factorized in real terms. Okay, it is like it cannot be resolved into linear factors. It is like a square plus b square, you can do a plus b whole square minus 2ab, but we are given that abc are complex numbers. Okay, so we can further simplify it. X minus 1 times x square, we can write plus 1 as negative I square, since I square is already minus 1, so negative I square will be plus 1, right? It's minus of minus 1. So now we can apply a square minus b square further in this second bracket. Okay, so this becomes x minus I times x plus I. Okay, So these are the three values of x minus a times x minus b times x minus c. This becomes this. Okay. So we have x minus a times x minus b times x minus c becomes x minus 1 times x minus I times x plus I. Okay. So first two terms are all right, no issue there. But if we want to equate both sides, we have to make the last term x minus something. Okay, it is x plus something. So let us introduce minus here, and then we introduce a minus inside this bracket and make it x minus of minus I. Okay. So now we can compare both sides. See, both sides are like x minus something into x minus something into x minus something, right? So on equating both sides, we get a is 1, b is plus I, and we get c is negative I. Okay. And we are given that these are all complex numbers. So b and c is right. It's all right. This is purely imaginary. And one that, sorry, not one, a equal to 1 can be further written as 1 plus I times 0, right? Any real number can be expressed in this form. Okay. So all of these satisfy the condition of being complex. Okay. So now let us find out the value of a plus b to the power 4 plus c to the power 4, right? The sum is almost completed. A plus b raised to the power 4 plus c raised to the power 4. So this gives 1 plus I raised to the power 4 plus negative I raised to the power 4. Okay. So this becomes 1 plus I to the power 4 is 1. Okay. And this is negative I raised to the power 4. Okay. So what I like to do is I cube is I square times I, and I square is negative 1. So this becomes negative I, right? So I'll plug in the value of I cube in place of minus I raised to the power 4. So we have 2, and this becomes I raised to the power 12, right? So I raised to the power 12 will be I to the power 4 whole cube, and I to the power 4 will be like I square times I square, which is minus 1 times minus 1, which is plus 1. Like I to the power 4n, I to the power 4n is always 1 for natural n, right? So I have done this. So this becomes 1 cube. So this becomes plus 1 cube. So this is 2 plus 1 and becomes 3. So the final answer is 3 for this question. To find the value of a plus b to the power 4 plus c to the power 4, if a, b, c are complex numbers and we are given that a plus b plus c is 1, ab plus bc plus ca is 1, and abc is 1. Okay, so we have just factorized x minus a times x minus b times x minus c. We have find the product here, then we have factorized it further in terms of um, linear factors, and we have combined both sides, and from there we have evaluated the value. After computing the value of abc, we have computed the value a plus b to the power 4 plus c to the power 4. Okay, so this was a short sum. Okay, thank you.